So good morning. I appreciate the opportunity to present on what is a very interesting topic. Drilling better wells is my title, and the challenge I've laid myself is, what are they? How can we create, measure, and reward them? So better wells definition, let me take you on a journey of a very complicated issue. I want to start out by noticing that this is not an easy task to describe. The drilling business or well construction business is really a complex system of systems, needs a complex system of systems appreciation. It is a complicated organization of various companies. And I also pick up on multivariant technologies and business models. It's not a standardized system of doing the business. And as was mentioned, life cycle valuation, this is the thing we have to really consider. And this involves lower cost and increased production. And with increased production, we start to look at net present value. So that is the value of the business over time. And as we look at the cost, we start to look at capital cost, which is often called capex, versus opex. Are you going to spend the money now on the well, or are you going to spend it later on maintaining the well? And then the schedule is really important. It does reduce drilling duration, which drives the capex, but it also improves the net present value, the economic value of the well. And then we look at the revenue stream determination coming from production. So this is the life of the well. How much will this well produce in terms of the rate at which it will produce and the volume it will produce? So how much of the reservoir does it actually extract hydrocarbons from? And how long will it keep on production? So talking about drilling being a complex organization of a system of systems, a few characteristics about that is there's not a single owner of results. We may think the operator is the owner, but there are multiple companies with different goals that determine the outcome of the well. So the operator is not owning all of the construction itself. There's no single root cause. I often get managers asking me questions about what's the one thing I need to do, the silver bullet. And I think we all know that there isn't one. So most of the causes of issues we have, or causes to make changes, are multifaceted. I mean, whenever you do an HSE evaluation of an accident, you find out there are multiple root causes. I remember Red Adair telling me back in the early 80s that when a blowout occurred, 5 to 9 things had gone wrong. So if 4 went wrong, you didn't get a blowout. But if you had 5 to 9, then you got that result. So it's multifaceted. Change is constant. In our business, when we get problems, they evolve and they require solutions that are adaptive. It's not often that you can quickly react and do something because there are more consequences happening through the process. And people say the system is working, so why change? I mean, I've been in this industry for over 40 years, and at the very beginning as a young engineer, I was told we've done it this way for the past 20 years. We're going to continue to do it this way for the next 20 years. So people say everything's working fine the way we measure it now, but it's not, and it needs to change. So there's resistance. It's a multivariant business and technology model in drilling and completion. And what do I mean by that? Operators used to do all the technology developments way back in the day. I mean, steerable systems, horizontal drilling, these all originally came from the operators. Now it's all coming from the suppliers. And the operators are exerting a pull on the kind of technologies they want to have. And that pull is usually exerted through business relationships. So the business and the technology have a huge interdependence. And I think that we know that the contracting process actually drives the technology selection that gets brought to the construction process of a well. These things are highly interdependent. And then we have deep technology. I mean, it's a pretty sophisticated business. And this deep technology comes from focused companies where we look at startups, and we can see that a lot today, particularly with digitalization, versus the major suppliers who bring along these deep technologies as well. And then technologies become common. I don't believe they become standard. So we could say that rotary steerable systems, or generally steering systems for directional drilling, are common, but there isn't a standard, and everybody's solution is slightly different. And then well valuation is life cycle driven balance of this capital expenditure or capex and the operating expenditure opex with the revenues coming in on the plus side. And capex is the well construction cost. And what we've got to remember here is it's not just drilling the well, it's actually completing the well. And I've seen presentations where in North America, this has been split out. So there's a budget for drilling and a budget for completion. And the completion guy complained that the drillers reduced their costs by putting in poorly designed frac packers. And then they came along with the completion and they were a lot slower in performing because of the selection of the packer. So there is a correspondence between the budget for drilling and the budget for completion. And then OPEX, what do we mean by this? There's routine maintenance. I mean, there's chemical injections, changing gas lift valves, things like this that go on routinely. And then there's light intervention with a workover rig or completion unit. And then we can go back into heavy intervention. Something can occur in the life of the well that requires a rig to come back and do a heavy intervention. Often this is brought back as capital cost. And then, as was mentioned in the introduction, we cannot forget the abandonment. And I think today people are beginning to realize that in the design and construction of wells, there are ways to do it that actually have no value during the production life cycle, but have value when it comes to an efficient abandonment process. And then net present value is the key criteria, which is driven by cost, revenue, and timing. So when is the money spent? How much money is spent? When does the revenue start? How much revenue occurs? And then the timing of these. Shorter schedules reduce costs and positively impact revenues, the starting time of the revenue. So this is a double benefit from a shorter schedule. It's not just impacting the costs. And then the revenue capability is driven by the well as a product. If we look at the well as a product, we have to look at how it can be operated to produce the hydrocarbons and lower the costs. And the shorter cycle, as I mentioned, reduces costs and positively impacts the revenues. It brings the revenue stream in earlier. So time cost reduction versus expense increase is one of the issues that drilling looks at. What's it going to cost to apply a certain technology? And what's the benefit in the duration or the cost of the well? So those two things tie together. And then early production has a hugely positive impact. Back in the day, working with a major operator, we used to say that if the well was delayed by 1 day, the barrels that we didn't produce in that 1 day were not produced the next day. They were produced or will be produced at the end of the well life. And if you discount the value of a barrel of oil at the end of the well, say 20 years later, and bring it back to today, you actually value it around $5 a barrel compared to what at the time was $20 a barrel. So it's worth 20 to get it out of the ground now, and it's only valued at 5 to delay it that much. So say 25%. So this is a huge lever to bringing wells on earlier. And then shortens the life cycle investment. So return on investment timeline. And again, I've mentioned NPV. So schedule drives the NPV, not just the costs. And then better wells are wells that deliver more value through their lifetime. And the question comes, what's the lifetime? And you can look at it at probably 20 years for a major well from a major operator, which is willing to invest the upfront money to produce for those 20 years. But it may only be as short as 5 years for the owner of a well that wants to actually sell the field late or in an early life and then move on in their business. So people, different companies can look at the life cycle of their valuations over different terms. And if we look at production reserves, we really want higher rates for longer. It's fairly simple. And how do we drive that from drilling? Well, one thing is wellbore data. The data that we collect while we're drilling drives the understanding and knowledge and reduces the uncertainty of the reservoir model, and also does the same for the mechanical earth model, which has an impact on production, but also has a significant impact on drilling and the risks of drilling. A better understood mechanical earth model enables a better design and a better drilling process. or more successful drilling process. And then the functionality of the well. What's its integrity? People are looking more and more at integrity today. And I think integrity is around the design of the well, but also the quality of how it was constructed. And then the flow control. What is the operability of this product, the well, that we can actually produce what we want to produce over the life of the well? And better production. How do we get better production? It's in reservoir percentage. And I think everybody's familiar with geosteering and geosteering into the reservoir. So it's the amount of reservoir that's intercepted by the well. But it's also lower skin. It's how the well was drilled into the reservoir and the formation of this so-called skin, which is a percentage measure of the wellbore resistance to flow from the reservoir into the wellbore, mostly caused by the drilling process, but it can also be caused by the production process. And then less liquid holdup. I'll come back onto that one in a little bit. And then better ESP positioning. There's been a lot of work done on ESPs that were positioned in a wellbore where there was microtortuosity that put bending loads onto the ESP that caused a short lifetime for the ESP operating. And work's been done to actually place ESPs where there isn't microtortuosity and get a lot longer life cycle. And then lower intervention activities with greater production control. So can this product of the well actually operate without significant intervention, which is extra cost, and actually control the production? And then drilling impacts production in many ways. And drilling cannot be absolved from this impact. I worked with drillers who look and say, well, the amount the well produces isn't under my control. And you turn around and say, well, it is, you have an impact on it. And if you actually don't get production, you don't get revenues. If you don't get revenues, you don't have a business case. If you don't have a business case, you actually might not be drilling wells. So one of the things is the interval in the reservoir zone, as I mentioned, and that's geosteering. I think most people are familiar with that. But then we come to formation damage. And I've worked with teams where we look at drill to the reservoir and drill in the reservoir and focus a lot on what's the skin effect impact in the reservoir and what can we do about it. There was one project in the west coast of Africa that produced 2,000 barrels a day from a 1,000-meter horizontal section. And we actually got the teams together, the subsurface, the completion, and the drillers, and we built a new process for the drill-in process to the reservoir and then the cleanup process of the completion. And the production went from 2,000 barrels a day to 3,000 barrels a day for very little investment. It was all about the process and getting the right people talking together. A lot of people say, well, I can correct the skin effect because I do perforation, which reaches through the skin, or I do fracking, which gets past it. What's really interesting is a major operator had a problem. They saw that their fracking responses globally had dropped off significantly, and they did a major investigation into this. And they found out that the drillers were using significant amounts of borehole strengthening as a technique to drill their wells more easily. And that same technique, the borehole strengthening, was preventing the fracs from forming properly. So again, there's a direct correspondence between the drilling process and the completion process to the reservoir. Now, coming back to tortuosity, this is a real issue. For me, dogleg severity is out of date. It's not a good measure. Dogleg DLS per 100 feet is all smoothed out. It's smoothed out between 2 points. And now we have high frequency or high resolution surveys where the survey points are taken every foot, the borehole survey points in the well. And using every foot, you can actually determine what the microtortuosity is. And if you use dogleg severity, you get a very noisy result. So there's been work done and published where people have come up with what's termed the effective diameter. And this now gives basically like a wormhole, three-dimensional description of the well and shows this microtortuosity. And then you can take a cylinder of a fixed length and a fixed diameter that represents downhole completion equipment or even casing into the open wellbore. and then you can pass it through to see how it impinges and if there's a problem or isn't a problem. One of the things here, of course, is this microtortuosity can end up with the casing displayed to the sidewall of the well bore in one place, and further up the well it's displayed to the other side. And when that happens, we all know the cement channels. And when the cement channels, we have an opening passing up the annulus, which is negative for production. And also these days, it's been seen as a negative for fracking because the frac pressure comes around the annulus and then compresses on the casing higher up. And there are now problems with casing collapse. And as I mentioned before, this microtortuosity gives you the ESP location. So actually drilling better wells in terms of microtortuosity, it has a huge benefit on the completion and lifetime of the well. And then porpoising is a lovely word. So I mentioned this liquids dropout. So wells that go up and down, it's now known that liquids drop out in the sumps along this porpoising as people try and intercept the most amount of producing formation. The liquids drop out. George King made a presentation a while ago where he talked about the liquids slugging up the well and into the separators. And apparently the slugging chugs away slowly, but then starts to get higher and higher in volume of the slug and eventually shuts down the separator. So this porpoising leads over time to shutting down the separator, which means shutting down the well, which means shutting down the production and taking corrective action. And then completion impacts production and costs. And I talk about the functionality. How will the well be operated? It's like you buy a product like a car. How do you operate the car? And then reliability, I see, is based on quality. So what is the quality of the functionality you built into this product that then determines the reliability of it, which determines your capex, how much you're expending on a better completion, and the opex, how much is it costing you to maintain it during its life. And then flexibility is based on the production profiles. Does the functionality have the capability to handle varying pressures over time and also changes between oil and gas or gas and water or oil and water ratios? And then one of the big ones we have, of course, for completion is sand control. When sand control is not undertaken or fails, there are huge problems with production. And it causes erosion, it causes separators to shut down because of the loading of the sand. It reduces production, reduces revenues. And then maintainability of the well. Can we use light or versus heavy intervention? What are the needs that we're going to have? And again, it's a design of balancing the capital cost of constructing the well with the operating cost through the life of the well. And then the completion design. I think we have to recognize that wells are designed to be drilled for a completion. And to do the well design, you start with the completion design. And some of the intermediate casings are just a means to an end to get the completion in the well. So actually wells are designed bottom up. So drilling has to take into account the completion, and completion has to take into account the production. And the challenge is to define the outputs of the drill completed well that will impact the production life cycle. And I think one of the issues we have is we have outputs that are under drilling responsibility, under completion responsibility, under geoscientist responsibility, and under shared outcomes from these multiple parties. And then we have operator responsibility, supplier responsibility, and then again, the shared responsibility. And all of this sharing of these responsibilities contribute to the costs and the hydrocarbon production. So everybody is involved in the result of the well. And the issue is to set meaningful targets and reward them. And this is very hard in our industry. I think we know and recognize that. Measuring individual and shared outcomes is very challenging. So what are some of the examples? In the planning levers, people look for optimized well concept. What's the best well concept to drain this reservoir? And then having selected that, what is the dollar per barrel that we expect to pay to get the barrels out of the ground? Zonal isolation, as I mentioned, is a big issue, and it's above the reservoir as well as through the reservoir. When you want to control production from different intervals, you've got to have zonal isolation. And then in target location, so again, dynamic geosteering. and it maximizes production and the reserves that are accessed. So it's the volume over time. And then the data acquisition targets. So how can you measure the targets for acquiring the data, which then improves the subsurface model? And again, this funny number, the skin factor. What is the skin factor expected, and what is the skin factor that resulted from the process? So it's complicated, and achievement requires a collaborative approach. So you have to drive alignment and then reward the collaboration. And then you've got to improve all the well drivers of results. So look at leading indicators when it's drilling the well, and then it's mostly lagging outcomes when you complete and produce the well. And under these, as I've mentioned before, is tortuosity, in reservoir, formation damage, and again, this porpoising issue. And then you've got to map the complexity of well construction. So to look at this system of systems approach, so you can actually map out how the various results contributing to the overall result actually align up together. And here, if we look at digitalization that's occurring in the industry, we see a change from separate products through interconnected services to new solutions. And this is a collaborated environment. And we're starting to see people are connecting the well plan, but the next step that's beginning to occur is connecting the well plan to field development. So the well is not just an isolated piece of business, it's actually part of a whole field development and impacts its production capability, its operability, impacts the facility's design and operation as well. And then there's 5 dimensions that I pulled out to create comprehensive system change for improved well outcomes. And I sourced these from basically the Toyota production system, which has led into lean manufacturing as a methodology. And in my business, I applied this to drilling under a trade name of lean drilling. And then there's an organization that has produced Systemcraft, have produced a look at complex systems globally. So it's not just manufacturing, and look at how they can change and achieve better results. So that's taken into account in these 5 dimensions. The first dimension is organized for collaboration. So you've got to build coalitions, and you've got to enhance the formal and informal architecture. You notice that don't say organization structure. It's very much about the architecture. How do these system of systems interact and work to deliver the result? And what is the formal and informal architecture? Because a lot of the informal architecture does drive the results and needs to be recognized. Set the direction, so set the ambitions and align the goals to this, and then create milestones and mobilize the resources. You got to harness the collective intelligence, so enable learning on systems functioning and changing, and then ensure information flows through the whole system. And then make it matter. You've got to forge an inclusive environment so people will connect together, and it has concerns and realities for them in what they are producing. And then change incentives. The bottom line is you've got to bring in incentives that drive the right behaviors. And of course, that's financial rewards in our business. And the Alliance formula has given a path to doing this, and vested contracts as well. And these are all about the implementation process, and then having a joint organization leadership. So a steering board governance for structure and behaviors. And the reason for this is in our business, it's so complex, you cannot make a mathematical formula to drive all the right behaviors. What you have to do is to have some flexibility and leadership to adapt as you go forwards. Outcome-based. This is the real core of it, that it's outcome-based. What is it you're producing that is going to do something for the user of that product, the well? And that these can be clearly measurable. And then we come back to leading indicators and lagging indicators. And then the pricing model, the one that's been used in alliances, is very much a gain share model. So the money you save on the construction cost of the well, you can then share with the companies involved in it and cap overruns and underruns. So there's a sharing of the benefits that are created jointly. And I found this quote from George Mitchell that I can't remember where I found it, but he said it takes an organized and cooperative team to create a transition. And it takes an active construction process to create such a team. And it takes a visionary leader to envisage and build the organization that will deliver the visionary goals. With that, I say thank you very much, and I'll take questions.
Right, so my question was, do we need a microphone, old fashioned here? We don't, because the microphones are actually here, so they do pick up any questions. Any questions from the audience? Yeah. Please do.
Shall I come to the microphone? Hi there, William Weldex. John, thank you very much for a very nice introduction. You captured a lot of what I was up to cover in mind. The question is definitely the cost of the well and its efficiency is defined by many factors. But if we try to systemize it and put like planning phase, well construction phase, and then production, where you see the most all the opportunities to excel?
So from my experience, the first step is to get the subsurface, the geoscientists, to collaborate with the drilling engineers designing the well. So sometimes that works well, particularly in smaller companies, but often it's the old silo is still there and they're not communicating the right information they need to. The next step is the drillers with the completion guys, and again with the geoscientists, and then production. I don't know how many times I've found out, go and visit production and ask, were they invited into the design of the wells they now operate? And they say, no, we just get given the well and we have to do what we can with it. So it's all about this collaboration across what have historically been different silos. Now, there's a big lever today is digitalization. So digitalization of the well planning process is actually enabling an environment where people can more easily collaborate and share data and then become far more efficient. So the people see a benefit from digitalization and the efficiency of their work, and then it actually causes this collaboration to happen. So it's a big enabler.
Thank you.
Don, did you get the question that was online? I know you were talking the majority of the time and answering this question. It just popped up. It was having to do with how do you manage the completion overall cost? I think you actually addressed it in your question. If you didn't.
I didn't see a question online, yeah.
Okay, no problem. Anyone else?
Yeah, hi John, can you hear me? It's Robin Macmillan.
Yeah, I can hear you, Robin.
Okay, so as you pointed out, there are certain collaborative rewards with regard to well construction, but because, as you also said, there's such an influence on production by the drilling guy, do you see any contracts out there where people are rewarded for example, initial production rate? In other words, being rewarded for production rather than just the cutting the cost of the construction of the well.
Yeah, in these alliance contracts in the North Sea, that has been one of the facets of the benefit in the gain share scheme. So that has been included. There were contracts where the production was outsourced to third-party companies. Down in Mexico, I saw this, and they were their rewards were based upon how much they increased the production from the well or from the reservoir. And so they started drilling wells to increase the production, but they also took actions in the drilling process to have better wells because they were making more money from it. But those kind of production enhancement contracts seem to have come and then gone. I mean, major service company was involved in a lot of those and they stepped back from that business. So yes, it has happened. I think the easiest place to look at it is in these alliance contracts.
Okay, thanks, Joe.